So today we'll be starting off with 3B part 3, which is diffraction. In this chapter, we'll learn about what is the meaning of the term diffraction, what are the different factors that affect the amount of diffraction, and we're then going to describe an experiment to observe the effects of diffraction as well. So remember, when a wave passes the edges of an obstacle, the wave energy spreads into the space behind the obstacle. And if the obstacle is relatively small, this can mean that the wave energy will pass around both sides of it and it will continue traveling past the obstacle with no shadow, as if the obstacle were not there, as shown in figure B. So here you can see that these are the waves. These are what? The wave fronts. Wave fronts are the imaginary lines. Can you tell me what were wave fronts? Do you remember them?
With the imaginary lines, right?
Right. So when you're traveling in an aeroplane and there's a rock, what will be the change in the shapes of wavelengths? You can see they have spreaded and they have divided
It
into
will
two.
go around it.
Exactly. And after a while, when they have crossed it, they are interfering with each other as well. They have superposed with each other as well. You can see these crossing over. This is the result of diffraction. If the obstacle is larger, there may be a shadow region behind it, but if it's still diffraction would be around the edge. If there are two very close opticals forming a gap, there would be more diffraction. Remember, smaller the gap, larger would be the diffraction. So,
Yeah.
what are different factors that affect diffraction? The amount of diffraction around an obstacle depends on the size comparison between the obstacle and the wavelength of the wave. As a resulting diffraction through a gap is caused by the diffraction at each end of the gap, and there is an optimum size for maximum diffraction or spreading through the gap. Diffraction happens most when the gap size is the same as the wavelength. अब सबसे ज़्यादा maximum diffraction कब होगी? When the size of the slit is the same as the wavelength, then that is going to be the most diffraction when it is exactly the same size as the wavelength. If the gap is too small,
Right.
very little wave energy can pass through. But if a gap is very large, energy would be very good क्योंकि वो undisturbed होगी. You can see over here there was a very large gap. So it went mainly undisturbed. Less diffraction, more energy transferred. But narrower the gap, more the wave bended,
More
more it
diffraction.
reflected.
hmm
Exactly. However, when the wavelength matches
But
the
it's not like rare fractions where it combines or like it.
rare fractions,
It is it like that where it will
it
compress itself?
that is a different phenomena that we'll study as well when we talk about different mediums in air, in water, in wood, in solids. वो अलग चीज है, वो अभी आएगा difference. Right now, the wavelength remains the
Okay.
same. That was a different thing. You are mixing it with refraction. Refraction was
Yeah.
bending of light. वो हमारा अभी next है. वो होता है जैसे straw. ठीक है, there's an image वो light के अंदर आता है. This is over here. You can see wavelength is same है. Over here, the wavelength is also the same. Over
Okay.
here, the gap is also the same. Gap is not changing. The lines are not becoming closer. The lines are still the same distance. Look at this and look at this. It's still the same.
Mm-hmm.
They are all equidistant.
Yeah.
So this is why we can hear around the corners as well, but not see them. The typical wavelength for an audible sound ranges from 15 centimeters to 15 meters, depending on the exact frequency. And these are the same sort of the size as common diffracting obstacles. For example, a doorway might be a meter wide, and a sound of this wavelength would have a frequency around 330 hertz, which is a typical speech frequency for humans. This means that a
hmm
conversation in a room could be heard in the corridor outside the door, and as the waves diffract from their original direction through the doorway to be heard out of the line of sight. However, visible frequencies हमें तभी hearing when it's gonna match. So one thing you have to remember, don't read all of this. There would be a maximum diffraction when the size of the slit matches the size of the wave or the wavelength. The diffraction
Okay.
pattern.
So
Mhm.
okay.
Yes.
So it is directly proportional to how open it is, the door.
Yes. ठीक है. No, नहीं, directly proportional नहीं है. Smaller the gap, larger the diffraction. And if the
Okay.
and if the size of the gap is exactly equal to the wavelength, then it would be the maximum. That's it. It's not directly
Okay.
proportional. वो different चीज है, ठीक है? वो उससे mix ना करना. Just imagine when you want a pipe, ठीक है? If you've seen a water pipe, when you want the water to flow at a pressure out of it, what do you do to the pipe's end? You press it
Can you say it again?
when you've seen a water pipe, okay? Now,
Yeah,
water pipe, may say it's a rubber pipe, water flows out like this. If you want it to
yeah.
flow at a pressure, what will you do? Squeeze it,
You pinch it.
pinch it. What will happen when you pinch it?
Yeah. There will become a smaller area, so pressure would become higher.
Exactly. More spreading. And if you even pinch it even low, to और spread करता है water को. Even if you
Yeah.
open the tap of water and if you press with your thumb upwards on the tap, what will happen? Spread होगा पानी. It's the same thing. ठीक है. You're narrowing the gap. जितना narrow करोगे उतना ज़्यादा diffract करेगा. So the diffraction pattern observed when light passes through a narrow slit shows a central maximum and then an area of darkness and then maximum. Up after they have passed in an obstacle or when they have passed through a gap, anything, they both cause diffraction. Either it's an obstacle or it's a gap. Now the two waves, okay, this was a single wave, but now they have become two, right? And now they are interfering as well at different
You're
points.
right.
Now we'll have some regions we call as,
So are these like if you would be sound, it would be like an echo where it would
this is not
come
sound.
back?
ये आपके पास examples of transverse wave है. Only transverse wave can diffract. ठीक है.
Okay.
Longitudinal wave की diffraction you don't have to study in AS. वो it's like PhD master's level. Very tough. वो आगे आएगी. So
Okay.
when you look at a torch, ठीक है, जो आप एक torch जलाते हो and you point it at the wall, what do you see on the wall? You see a big circle
Yeah.
and then you see a darker region, then you see a brighter region, and the middle one is the brightest, right?
Yeah.
Why is that so? And when you take this torch closer to the wall, क्या होता है? This circle becomes smaller and more bright,
Yes.
and then a dark region,
So.
and then a bright region. वो circles form होते हैं. This is also
Mhm.
diffraction. We'll have different areas क्योंकि जहाँ पे ये join करते हैं, अब two waves है ना, अब वो जब interfere करेंगे after spreading, some of them would produce a maximum bright region. Some of them would produce a dark region. Then some of them again would produce a maximum bright region. Now, how is that done? By interference. This is all due to the interference. Okay? Considering the waves being diffracted from each end of the slit gives us two waves which will meet at the screen. We saw this and the waves meet in phase, so they will superpose as well to give a larger amplitude resultant wave. And this would appear as a light spot on the screen. At a slightly different place on the screen, these two waves will be completely out of phase and the sum of their displacement will be zero. अब when they interfere, ठीक है, मैं यहाँ पे दो slits बना, this is one slit, this is the second slit, there is one wave coming, and once this wave is going to pass through the slits, what will happen? It's gonna turn into
They would
two, ठीक है, एक
smaller.
is separate और ये वाली wave separate हो जाएगी. Got it?
Yeah.
Now these waves are starting to interfere. There would be many different points of interference. Some of them would cause maximum, some of them would have a minimum, someone would have a minimum, फिर एक maximum, फिर एक minimum. वो कैसे होगा? Look at this laser which diffracted. Now the laser had different points, maximum regions, minimum regions, maximum regions, minimum region. ये देखो कहाँ पे कहीं पे light है भी नहीं. These points where there is no light,
Yeah.
we call these minimas. And the points where there is light, bright regions, we call these maximas. Look at this. This is the brightest maxima,
Mm.
first maxima,
Yeah.
second maxima, third maxima. Then ये है zero maxima,
Minima.
first maxima, second and third. Minima
Right.
zero नहीं होता. Minima always starts from one minima, one minima. Then this is the second minima, second minima. Got it?
So the space in between are minima.
Where there is no light,
The empty
dark
space.
regions. ठीक है,
Yeah.
minima are known as the dark regions, maxima are known as the bright regions. अब maxima कहाँ पे होता है?
Right.
Because now there are two waves that have integrity. ठीक है, आपके पास ये दो waves हैं. ठीक है, this is another wave
Right.
and this is another wave. Now at some points, the waves are going to superpose constructively. That's the point where they will show maxima. Constructively का क्या मतलब है? कि the two waves were exactly in phase with each other. But at some
Yeah.
points, such as this one or this one, यहाँ पे they will meet destructively because
Okay.
Waves are out of phase. यहां पे आपके पास बनेगा मिनिमा. वाई मिनिमा? क्योंकि जब आउट ऑफ फेज वेव मीट करती हैं द रिजल्ट इज जीरो.
Zero. They will cancel each other out.
एग्जैक्टली कैंसिल हो जाते हैं. लेकिन जब वो ऐसे पॉइंट्स मिलेंगे वेयर देयर क्रेस्ट एंड ट्रफ आर अलाइन, दे आर सिंक्ड विद ईच
Mm-hmm.
अदर. ठीक है, वहां पे
They will
देयर
become brighter.
डबल और वो ब्राइट रीजंस बनाते हैं. सो कंस्ट्रक्टिव
Right.
इंटरफेरेंसेस कॉज मैक्सिमा, डिस्ट्रक्टिव इंटरफेरेंसेस कॉज मिनिमा. इसी तरह डायफ्रैक्शन ग्रेटिंग भी यही चीज होती है. मल्टीपल डायफ्रैक्शन पैटर्न्स बनते हैं विच देन ओवरलैप. This creates an interference pattern with a mathematically well-defined spacing between bright and dark spots, and it is a collection of a very large number of slits through which the waves can pass. अब यहाँ से आगे हमारे पास कुछ फॉर्मूला आते हैं. एक दफा इसको एक लाइट रूम में देख लेते हैं. What does actually this interference looks like? There is a single slit interference as well. There's a double slit. क्योंकि एक बहुत common question है that when you're trying to superpose two waves, you have to make sure they are monochromatic. Monochromatic mean या coherent. They should be coherent. मतलब they should have the same wavelength, same frequency, same light, same color.
Are you?
ठीक है? नहीं नहीं, I'm not sharing the screen.
Mm-hmm.
Now, how is that
Okay. All
possible?
right.
ठीक है? People thought that if we want two waves to diffract, they should be coherent. अब ये कैसे पॉसिबल है दैट यू ब्रिंग टू लाइट सोर्सेज व्हिच हैव एग्जैक्टली द सेम वेवलेंथ, एग्जैक्टली द सेम फ्रीक्वेंसी? इट्स नॉट पॉसिबल. सो व्हाट दे डिड टू कॉज इंटरफेरेंस, दे यूज्ड अ सिंगल लाइट सोर्स बट मेड टू स्लिट्स, ताकि वो एक ही लाइट सोर्स दो में डिवाइड हो जाए. बिकॉज इट वाज इम्पॉसिबल
Okay.
टू ब्रिंग टू लाइट सोर्सेज ऑफ एग्जैक्ट. नाउ हाउ कैन यू फाइंड टू टॉर्चेस? ठीक है, try finding two flashlights which have the exact darkness, exact color, exact brightness, exact frequency, exact wavelength. It's not possible. It is
It's not
not
possible now.
possible. ठीक है. So what they did to cause this interference, scientists ने कहा, why not use a double slit? Use a single light source, but make two holes, ताकि वो light source
So
दोनों में
the
से pass
okay.
कर जाए. Got it?
So the basic. Yeah. Okay.
Exactly. ठीक है, तो वो उस तरह हो जाता है. Where is that interference? ये तो overlapping है. Okay, yeah, I've got it. Let's watch this video. It's a full. हाँ, ये देखते हैं.
Hey, it's Professor Dave. Let's talk about interference and diffraction.
He knows a lot about the science stuff. Professor Dave explains.
We know a bit about wave mechanics now, so it's time to look at some wave-related phenomena, like what can happen when two waves overlap, or when a wave runs into some solid surface. These are very common occurrences, as we are frequently experiencing sound from more than one location at once, and sound will bounce off of walls and other surfaces, so we need to understand what happens to waves in these scenarios. We know that two solid objects, like two people, can't occupy the same space at the same time. But mechanical waves are not matter. They are displacements of matter that carry energy. So two waves can occupy the same space. And when two waves combine in this way, it is called superposition. When there are two disturbances near one another and their respective series of waves overlap, this is called an interference pattern, and we can see how the regions where the waves intersect generate a completely new pattern. This is easy to see with waves in the water, but sound and light waves also do this. There are a few different things that can happen when interference occurs. Say two individual wave pulses are traveling towards each other, and they have the same amplitude. When these meet, the amplitudes at each point will be added together to produce the respective points on the resultant wave. So there will be a moment where there is one wave with twice the amplitude. Then the two waves continue in the direction they were moving in. Each wave maintains its own characteristics before and after the interference. When a resultant wave has greater amplitude than the individual waves, like this case, this is called constructive interference. Now let's say the pulses are on opposite sides of the equilibrium position. Again, according to the superposition principle, we will add the amplitudes to get the resultant wave. But in this case, the two amplitudes add to zero. So the resultant wave will be as though there is no wave at all. Then the waves continue along their trajectories. This kind of interference, where the resultant wave has a smaller amplitude than the individual waves, is called destructive interference. And if the resultant wave has an amplitude of 0, like this example, it is called complete destructive interference. This concept applies to periodic waves as well. First, we can consider two sine waves that are precisely aligned. They are said to be exactly in phase. We can add the amplitudes at every single point, and the result is a similar looking wave with twice the amplitude, due to constructive interference, because the crests align with the crests and the troughs align with the troughs. But then, if we shift one of these by half its wavelength, now the crests of one align with the troughs of another, and at every single point on the x-axis, these waves will add up to 0. They are said to be exactly out of phase, and this will be an example of complete destructive interference. This is what noise cancellation headphones do. Small microphones detect background noise and process the associated signal, and then reproduce this noise in a way that is precisely out of phase with the signal. The resulting destructive interference results in 0, or at least dramatically reduced sound waves reaching your ears. In reality, interference patterns are often much more complicated than these two extremes, but in every case, the superposition principle is still applicable. We also want to understand what happens when waves hit a boundary of some kind. If a boundary is free to move, waves will be reflected, bouncing back in the opposite direction, but maintaining the same amplitude. If instead this boundary is fixed, waves will be both reflected and inverted, bouncing back in the opposite direction, but now with amplitude of the opposite sign. Let's say instead of arriving at a solid boundary, a wave arrives at a boundary with a small gap in it. When waves reach an opening like this, they will bend around the edges, producing a phenomenon called diffraction. A diffraction pattern is another kind of interference pattern because of the series of maxima and minima that result, and waves of all types will exhibit this behavior. It was the diffraction of light that provided some of the strangest data we have collected in physics, contributing to the development of quantum theory. But that will have to wait until the modern physics course. For now, let's check comprehension.
So can you tell me the answers of both the fill in the blanks?
When the resultant wave has a greater amplitude than the individual wave, this is called interference.
And the second one?
When the resultant wave has lesser amplitude than the individual wave, this is called this is the diffraction.
Now
Okay.
check what did you do.
Yeah.
When a resultant wave has a greater, what is the meaning of resultant? Can you tell me?
The opposite wave, like
Wrong. Resultant is the product. Resultant force क्या होती है? What is resultant force?
the total force,
तो फिर resultant wave क्या होगी? The total wave,
the total wave.
which is made by the product, ठीक है, by two different waves
Yeah.
combined. ठीक है, so resultant wave has a greater amplitude, which means that it is made from two waves which have the same phase difference. So it's constructive interference. But when a resultant wave has a lesser amplitude than the individual waves, that is destructive interference because that is 0. Product 0 aa jata na. Is it
Right.
clear? Then what is diffraction? Why do
Yeah.
you say diffraction then? Define me. What is diffraction?
Diffraction is the what we'd call the when you wave spreading around the obstacle, but
Yeah, then how is the second option
that was
diffraction?
wrong.
It's a spreading of
I
a
don't
wave,
know.
different cheese है.
Yeah.
Good.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon.
Now we'll study a formula which is known as n lambda is d sine theta. Okay, so if I give you an overview, let's open up a whiteboard and we'll talk about what we have studied in interference. So can you tell me what is the meaning of superposition?
Super what? Super
Superposition.
superposition. I feel like I've heard it before, but
We have done it in the last class. We have done it today.
yeah, I know. That was it was when were interfering, I think.
We'll do some practice today. Okay, if we are rushing the syllabus, you're not revising anything, so it's no use if I teach you very quick. So we'll slow down our
Okay.
speed now because इस तरह तो नहीं समझ आएगी. There's no point of rushing the syllabus if there's no revision as well. Let's do some practice afterwards now today. Okay, so there are two slits over here, and we can see that they have diffracted. Got it?
Yeah.
Okay. Okay, now you can see that they have interfered at many points. Now the middlemost point जो है जो बिल्कुल आपके पास middle के अंदर आता है, let me draw a line. This one, ठीक है? This is एक ये point आ रहे, फिर और कौन से point आ रहे हैं interference के? These one as well. फिर there's
All right.
more points of interference such as these ones, for example, ठीक है? फिर आपके पास और आएंगे random points जैसे कि यहाँ पे भी और बनेंगे. I haven't drawn the wave yet, but still just giving an example.
Mhm.
अब different points आते हैं, ठीक है? Now constructive interference और destructive interference कहाँ पे होगी? We are going to talk about that. Can you tell me the difference between both of these?
Destructive interference would be when they are opposite in direction, will mean they would
Wrong.
cancel out.
Wrong.
Isn't it destructive interference?
No.
When one is moving in opposite direction,
No.
so when they pass each
Opposite
other, they
मैंने
will
कभी
cancel it.
I've never used the word opposite anywhere. Destructive doesn't mean opposite direction. It means two waves which are out of phase. They are moving in the same direction, but they are out of phase from each other. They're not in the same phase. Their crest is not matching the other one crests. One crest is matching the
Right.
trough of the other wave. Constructive क्या होती है then?
Constructive is when they are in sync, so they would have a higher total amplitude.
Explain me again. What do you mean sync? Sync का मतलब क्या है?
When they're in phase, so
In phase, ठीक है? When the first wave's crest matches the other wave's crest, trough matches the other wave's trough, बिल्कुल in phase होते हैं. अब जो in phase points होंगे, they are always going to make maxima. ठीक है? अब यहाँ पे दोनों waves के crests
yeah.
are matching the crest, ठीक है? Troughs are matching, वो maxima बनाएंगे. फिर जहाँ पे destructive interferences होंगी, they are going to form minimas. And again, then there will be constructive interference. वो क्या बनाएंगे? Maximas.
Yeah.
Now, this would be the zero order maxima, and these would be the first order maxima, and these are the first order minima. Okay, this is what you need to know right now for destructive interferences. Maximas are made by constructive interferences,
Yeah.
and minimas are made by destructive interferences. Minimas क्या होंगे? जब crest would be meeting the trough of the other waves. ठीक है? और constructive interference क्या होंगे? When crest meets the crest of the other wave, या फिर trough meets the trough of the other wave. ये होता है, मतलब कि they are in phase. वो दोनों waves in phase में जा रही हैं. This is wave 1, this is wave 2. ठीक है? ये थी एक single wave ही. But after they passed through the two slits, they divided into two different waves. It was a single source. It was a single source, but it was a double slit.
Okay.
Got it? Good. Moreover, कंस्ट्रक्टिव इंटरफेरेंसेस में जो दोनों वेव्स का फेज डिफरेंस होता है, that is either 0 or it is 360. But when we talk about destructive interferences, the phase difference is either 180 between the two waves or it's 270 because they are out of phase. इन दोनों में phase difference या 180 का होगा या फिर 270 का आ जाता है. Got it?
Yeah.
ठीक है. If we talk in terms of radiance के term में we can say that जो constructive interferences होंगे उनमें difference या फिर pi का होगा. Either the difference would be of you can say a pi or 2 pi. But destructive interferences में difference होगा 3 pi by 2 का या फिर it would be pi by 2 का difference. Got it? Pi by 2 is
Yeah.
180, 3 pi by 2 is 270. फिर
270.
आपके पास होता है नहीं बल्कि पाई तो वो होगा ना, सॉरी 180 आपके पास हो गया पाई बाय 2. 2 पाई इज गोइंग टू बी 360. ठीक है. और ये ठीक है. गुड हो गया. इज इट क्लियर?
Yeah.
इसको पाई गुड हो गया. Alright. Now let me show you the double slit experiment and we'll see how is this interference pattern caused. Interference diffraction. So now can you tell me what is the principle of superposition that we did yesterday?
What?
What is the principle of superposition? There was
Principal
a
superposition.
principle of superposition.
When the two or more waves overlap in space, which will result in disturbance, which would make it equal. So, yeah. Was that when two or more waves overlap, right? And which would cause it to basically cancel it out. No, it will not be in sync and it will become zero.
Principle of superposition means that when two coherent wave sources of the same amplitude, same wavelength, superpose or interfere with each other, the resultant wave's amplitude would be the sum of both the individual waves displacement. That the resultant displacement would be equal to what? जो दोनों individual waves की displacement थी, their sum. Got it?
Yeah.
This is a very common question in AS, ठीक है? And it is always the part A of every question. Every question's part A is almost like defined diffraction. What is the principle of superposition? What is interference? तो ये exact definitions from the book आनी चाहिए. There's no guessing. There's no your own words. You don't have to use your own words. You have to use the book's definition because it's very easy. Examiner won't give you marks, single mark if you use your own words as well. Got it? Good.
Yeah.
स्टूडियो कॉन्सर्ट दुबई में देखने का मौका.
Diffraction of light waves through an aperture. In our earlier session, we have learnt about diffraction. Now let us learn how the light waves get diffracted at an aperture. According to definition, the bending of a wave or its deviation from the original direction of propagation when it meets a small obstacle is called diffraction. The wavelength of the light waves is 5000 angstrom, which is very less compared to the wavelength of the water waves and sound waves, which are about few centimeters to meters. As the wavelength of the visible light is small, comparing to the wavelength of the incident waves. Hence, for experimental observation, diffraction of light waves needs small-sized obstacles. As we learnt earlier, according to rectilinear propagation of light, when light falls on the opaque object, geometrical shadows of small opaque objects should be formed. But as the obstacles are small, the light wave bends along the corners of the obstacles and slightly spread into shadows, and thus they are not sharply defined. In the case of monochromatic light, when the light wave is incident on the small object, like hair, or a sharp edge object like blade, due to the geometrical shadows are formed with dark and bright fringes. Thus, diffraction is defined as the bending of light waves around an obstacle whose dimensions is comparable to the wavelength of the incident light, and hence its spreading into the geometrical shadow.
All right, now let's solve some practice questions. I'm going to write them on the group and then you're going to solve them right now. Got it?